polynomials. Before we do that, let's come back and do some real quick review. Polynomials are classified by the number of terms. In other words, things in terms are separated by plus or minus signs. So a monomial has one term, binomial has two, trinomial has three. Polynomial is a sort of a general term. It means one or more terms. Okay? The degree of a polynomial. Sometimes people refer to this as the order of a polynomial. It's the largest exponent that's present. And you're going to need to be able to pick these out. It's not hard to do. Let's take a look at an example. X squared plus 3x plus 4. All right, take a look at this. You notice I've got a plus here and a plus here. So here's one term. This is term 1, term 2, and term 3. Since I have 3 terms, this is a trinomial. The largest exponent I've got on a variable is 2. So my degree is going to be 2, which is a quadratic. This is going to come into play later on, especially when we deal with higher order polynomials. This tells you how many zeros, potential zeros you have. Okay, so that's our degree, and this is how you do it. So term 1 will be x squared, term 2 is 3x, term 3 is 4. Adding and subtracting polynomials. Big deal here is grouping like terms. Okay? And before you do it, remember in subtraction, distribute the negative. Let's take a look at an example here. I'm going to have x cubed plus 6x squared minus 4x plus 7. And I want to subtract 3x squared plus 2x minus 4. I've got subtraction here, so the first thing I'm going to do is distribute that in. I'm going to have x cubed plus 6x squared minus 4x plus 7. And if you remember back to Algebra 2, we called this clearing the grouping symbols. We're getting rid of our parentheses. I'm going to do minus 3x squared minus 2x. So I've got to distribute this into here, and also have to distribute it into there. Negative and a negative gives you a plus 4. And now I come back in, and I group all of my like terms. So I only have one x cubed, so I put that down there. You notice I've got an x squared here, and one here. So I'm going to have plus 6x squared minus 3x squared. Then I've got a minus 4x minus 2x. Then I'll have plus 7 plus before, and now I combine all my like terms. So I only have 1x cubed. I've got plus 6x squared minus 3x squared. That'll give me plus 3x squared. I've got minus 4x minus 2x, negative 6x, and plus 4 plus 7 plus 11, and there's your answer. This should look pretty familiar to you. The important thing to remember is when you've got subtraction, distribute the negative term into everything behind it. Okay, let's talk about multiplying these guys. So let's multiply two binomials. There are two ways of looking at this. We can do the FOIL method, which stands for first, outside, inside, and last. So what this does is you multiply the two first ones first. So you get x times x. Those are my two first ones. Then we do the outside, which is going to be x times a negative 2 minus 2x. Then I do the inside terms plus 3x. And then I do my last terms, which will be minus 6, 3 times 2. I come in and do this, I've got x squared minus 2x plus 3x minus 6. Okay, now the other way to think about this is instead of FOIL, if you don't like it, just think about distributing. So you start with the first term here, your x term, and you distribute it to everything in the other one. So you distribute that x to the x over here and to the negative 2 over here. Then you take your 3 and you distribute it to this x, and then you distribute it to the negative 2. This is going to be helpful if you've got another term out here. For instance, I got a binomial, trinomial. You just have to remember to distribute this into this term, then this term, and then whatever this term out here is. And I don't care how you do it, it's going to give you the same answer either way. Okay, so let's get to our big idea, and let's set it up. Factoring. The first thing you should always do when you're faced with these type of problems is look for something in common in all of the terms. So don't even think about the normal factoring, but come in and see if there's something that's in common in all of your terms. And let's take a look at an example here. 2x cubed Okay, so what I do is I start on my left to the right. So what I have in both terms, and I'm going left to right. So I've got a 2 here and a 6 here, but that 6 you can think of as a 2 times 3. So I've got a 2 in both of these. So I'm going to have a 2 in both terms. Okay. Then I'm going to come back in, I'm going to look at my x's. So I've got an x cubed here, which is x times x times x. And I've got an x here. So what I have in common in both terms is 1x. Then I come back in and I take a look at this guy. And I notice that this is the same in both of them. So I'm going to have a y minus 3. All right, now when you multiply all of these together, you get the term that's going to go out in front of all of this, what you're factoring out, or you can think of it as dividing out of everything. So we're going to multiply all of these together. So I'm going to have a 2x times y minus 3. And that's going to go out in front of a bunch of mess over here. So I'm going to divide a 2 out of here. So that leaves me with a 1 that we don't write. Then I'm going to divide an x out. X cubed divided by x gives me x squared. And then I'm going to divide a y minus 3 out, which will just leave me with a 1. So all I'm left with after divide this term, this stuff out of this term, is just an x squared. So I'm done with this one. Plus, now I've got to do the same thing to this term over here. I'm going to factor or divide a 2 out of here. That's going to leave me with a 3. And x out of here is going to leave me with a 1. And y minus 3 is going to leave me with a 1. And that is your factored form of this guy right here. And this would be really nice when you solve and set them equal 0, because you set that equals 0, set that equals 0, and set that equals 0, and you solve each one individually. Okay. Now, another thing sometimes you'll pick up is going to be something like, well, before I do that, let's take a look at our old friend factoring trinomials. And by the time you're done in here, you should be able to look at these and tell what we've got. So, first thing we do, remember this is our A term, here's our B term, and there is our C term. So find factors of your A term. In my case, my A term is 2, so my factors are going to be 2 and 1. And you really want this to be a positive number, if at all possible. Okay, so that's good. We've done that. Now we come in and we find, now you guys have done this with the box method, and if that's what you like, that's fine with me. Let's find factors of a C term, which is 3. So the only factors there are going to be 3 and 1. All right, we're going to factor this into 2 binomials. So I know my leading term are going to have x's in them. But I've still got to take care of this 2. So this is where I get my factors. So I'm going to put a 2x here. It doesn't have to go in the first one. It can go in the second one, but either way. Now, I'm going to take my C factors and put them in. Now, you don't necessarily know where they go. So let's try. I'm going to have trial 1. And I don't really know necessarily where they're going to end up going. So I'm just going to come back in and put them in somewhere or other. And what I want to do is make sure that these things add up to 5. Okay, so 2x times x is going to give me 2x squared. That's good. 1 times 3 gives me 3. But my problem is going to be my inside and my outside terms. And I want those to add up to 5. So first thing I do is I'm going to multiply 2x by 3. That gives me 6x plus x, which is 7x. So trial 1 is a bust. It doesn't work. You don't give up. You just switch your C factors and try again. So let's do trial 2. I started off with the 1 here. Okay, so let's put the 3 first. And since the 3 went first, the 1 is going to have to go last. And again, we try this. So I'm going to do 2x times 1 gives me 2x plus 3x, 5x. So this is my factored form. All right? Now, if you've got more than just one pair of factors for A, try the two that are closest together. Come back and work with your factors of C. And you just keep trying it until you get the right thing. Okay? So I know since this worked, this is what I'm dealing with. All right. Know the formulas in the blue boxes on page 26 and 29. You're going to see a lot of those. These are forms which occur a lot. And if you know how to do these, it's going to make your life a lot easier. And you'll be able to go through and do things a lot faster and a lot slicker. Okay. Last thing I want to talk about on factoring is a thing called grouping. And this is used for higher order polynomials, 3 or greater. It's usually not used for second order polynomials. And let's take a look at one of these. Now, the idea behind grouping, and it doesn't work on everything, but it does work on a lot, is group your highest order terms together. And lowest order terms. All right, so in general, this is what we're going to do. So that's the first thing, is we're going to group them. Remember, grouping involves parentheses. Then you're going to factor your groups. You factor each group. And then you look for something you can factor out of both. Now let me give you an example of where this will work. So look at this guy, x cubed plus x squared plus 4x plus 4. Okay, now the first thing I would want to do is I'm going to look and see if there's anything in each of these terms I can factor out. And there's nothing that is in all 4 of those terms. Okay? So, this is a cubic. This is not nice. What you're going to do then is you're going to go in and try grouping. Remember I said to group your highest order terms. So we're going to group these two together. And then we're going to group these two together. So let's come down and write our groups. So I'm going to have x cubed plus x squared plus, I'm going to have another group 4x plus 4. Okay, now I come in and see if there's something that I can group out of this guy. My coefficients are all 1, okay? Here I've got x times x times x. Here I've got x times x. So what I've got in common in both of them is x times x, which is x squared. I'm going to factor that out. X squared times. Okay, now I'm going to divide my x squared out of this term. I'll take it out. All I'm left with is an x. Plus. Okay, now a lot of people forget that. They say, I've taken an x squared out of it, so I'm left with nothing. No. X squared over x squared is 1. Guys, any number over itself is 1. So you put a 1 down here, because all that's left when you take that out is a 1. And if you want to check that, distribute back in, and you'll see we got back what we have. Now on this one, I've got a 4 in both of them, but I don't have an x. So I can factor a 4 out of both of these, and I'm left with an x plus 1. Okay, so now I want to take a look and see what I got. I've got an x squared here. I've got nothing here. I've got a coefficient here, but I don't have one here. So there's nothing I can factor out of that. But most of you are probably sitting there beating it, saying, hey, stupid, you do too have something in common, and you do. You've got the x plus 1s. So what I'm going to do is factor those out. So I'm left with an x plus 1 times. Now, this term, when I come back down, it'll divide an x plus 1 out. All I'm left with is my x squared. Plus, I'm going to divide an x plus 1 out of here. So I'm left with is my 4. And now you got this thing factored. And what you see is you've got something which is a lot easier to solve if you have to do it. So this is your algebraic expressions. It's very